Hi everyone, we are Dyah and Whenty. We'd like to present our final project entitled Incorporating Graph-Based Positional Dependency Features to Improve Punt Result Classification and Play Type Recommendation for NFL Big Data Bowl 2022. So first, we'll talk about our problem statement. So understanding what aspect that can lead to scoring is needed for the coaching staff. Thus, we would like to leverage the position information of the player in the field as the additional information that can be used to improve the game strategy prediction. But in order to do that, we model the position of the player in the field as a graph and extract the neighborhood information as a graph-based positional dependency features. We also strive to seek more suitable techniques that fully utilize the neighborhood information. And these are our main contributions. So first, we propose a graph-based positional dependency features using GCN to improve the game strategy. And the second, we propose graph-based CNN BLSTM as the best model that can fully utilize our graph-based positional dependency features. And third, we evaluate our graph-based positional dependency features on two different tasks, the punt result prediction and play type recommendation. In this section, we'll talk more about the data analysis. So we use the NFL Big Data Bowl 2022 as our data set. It contains of play data, tracking data, PFF coding data, player data, and the game data. Here in the left figure, you can see that the distribution of the special teams play type in this data set. So other than the player data, we extract another feature which is related to the social network called a positional dependency feature. And in this section, we would like to explain more how we model the positional dependency. So for the positional dependency modeling, we model the position of the player in the field as a graph with each vertex representing the player and the edge that connects every two players represent the geographical proximity between them. And we model two communities in this graph, home team and the visitor team. And then we construct this graph and fed it into the GCN node classification task and extract the last hidden layer to get its graph representation that can be used as the positional dependency features.
And one of the issue in classification is how to deal with imbalanced data. Dealing with imbalanced data is a prevalent problem while performing classification on the dataset. This problem may cause bias while making a decision. In this work, we adopt smooth technique for handling imbalanced data. Smooth is one of the most popular methods for performing oversampling because the previous methods such as random oversampling can lead to overfitting because of randomly replicating the instance of the minority class. In Smooth, new instances are created based on interpolation between several minority class instances that lie together. This allows Smooth to operate in feature space rather than operate in the data space. And next section is about our classification task. So this is our graph-based CNN BLSTM model architecture. We have two input, the player embedding and the location dependency feature. We concatenate these two together and fit it into the CNN layer to extract the final embedding feature. And this CNN model built by employing two convolutional layers with a 256 and 64 filter, and the feature map of convolution layer are downsampled by max pooling layer to keep the important feature. And by combining the CNN and BLSM together, our framework improves the discriminative ability of feature. And this is our experimental result. We compare our result with the baseline from the challenge. The baseline, they use several machine learning models to do the classification, and the result clearly show that even only considering player-based feature, our proposed ensemble learning and DNN model outperform the other method in supervised pun result classification. And we do fair comparison with the baseline by using the same feature. And the highest accuracy obtained by our proposed DNN model was 71%, which is 1% higher compared to the best baseline model from the challenge, which used the XGB classifier. And we would like to improve our classification performance by incorporating graph-based positional dependency feature. And we also apply our graph-based feature to the baseline and see the performance whether this graph-based feature can improve the classification performance in any models. And considering our previous result, which show that the deep learning model outperformed compared to several machine learning model, and here we adopt several deep learning based approach to build the classification model, and we propose CNN BLSTM approach. And all of the classification result accuracy improve after we incorporating graph-based positional dependency feature. And compared to overall model architecture, our proposed CNN BLSTM model obtain the highest precision recall and F1 score and the accuracy which is 81.4%. And the figure on the left side is the loss and accuracy performance of several deep learning model compared to our baseline. Compared to our proposed CNN BLSTM model. And on the right side is our hyperparameter that we use in this work. And also it can be seen our classification report using our graph-based CNN BLSTM model, which obtain 81.4 accuracy. And to observe the behavior of this approach for the combining effect of class imbalance, we are considering smooth algorithm. This figure summarizes the result obtained after performing graph-based positional dependency feature by using CNN BLSTM on by varying the accuracy and the running time during the sampling. And for traditional classification, if we are decreasing the imbalance ratio, then the classification accuracy will increase. In case of smooth, the performance of classifier increase in both 8 and 16 GCN embedding size. And from this result, we can observe the risk of using imbalanced data for prediction without preprocessing, which also reflect the critical need to perform preprocessing on the data.
In this part, we will explain more about our recommendation task. So this recommender system is built to help the coach to make faster judgment during the game. But it only considers two main play type, which is punt and the field goal, as our play type prediction. So first, we will predict the probability for each play type given the parameters of the current circumstances by calling the play type prediction model. Then the play type prediction model will recommend the play type with the highest probability. If the recommended play type is punt, then it will advance to the punt strategy prediction, which predict the probability for the several kick type and direction. And then the recommender system will recommend the punt strategy with the highest probability. And from this flow, we can observe that there are two main models in this recommender system. The first is the play type prediction, and the second is the punt strategy prediction. So here, our goal is to improve this two model. So in the original work, they only use a player-based features. The results of the two models with the player-based features can be seen in the first row. And then we want to incorporate our proposed features to the original model. So in the second row, we can see that there is a model with a player based with graph-based positional dependency features. The result shows that the model with our proposed GPPD features has better accuracy compared to the existing works. This demonstrates that the GPPD managed to model the positional dependency for the player, specifically the kicker in the field, which express the power of the positional influence. However, since determining best strategy depends on the coach himself, we leave the exploration of evaluating the recommended strategy in the future work. And the conclusion of our final project is, first, this project proposed a graph-based positional dependency to model the neighborhood of the player in the game. By modeling the neighborhood information as a graph and extract its information to improve the game strategy. And the second, we evaluate our performance in two different tasks. First, it is special team result prediction and the play type recommendation. We also use graph-based CNN BLSTM model for the classification task, and proposed model can outperform the several deep learning models with a considerable improvement in terms of precision, recall, F1 score, and accuracy. We also use GPPD features for recommendation tasks, and it performs better than the existing works. And for the future work, we need to explore the effectiveness of the proposed model with a deeper layer and diverse architecture, especially on the GCN embedding size for extracting features. And the second, the exploration of evaluating the recommended strategy in the future work for determining best strategy. That's all for our presentation. Thank you very much for listening.